Hi, welcome to Section 3.3, CP/CTC in Circles. Our objective is to apply CP/CTC and to recognize the properties of circles. For homework and during class, we're going to be working on pages 127 to 130, numbers 1 to 5 odds, and 9 to 21 odds. So the first thing that we're going to talk about is CP/CTC. CP/CTC stands for corresponding parts of congruent triangles are congruent, which means that the matching angle and sides of corresponding triangles are congruent. Now, let's kind of put this into normal people words so I can show you what that means. Let's say that I have two triangles. And with my two triangles, let's say, for instance, I know that they're going to be congruent by side angle side. Let's put some letters in here. A, B, C, D, E, and F. Now, we can see, and from our last lesson, we know that these triangles have a side angle side congruency, two sides in the included angle. Now, what that means for us is that we actually have three pieces of congruency that weren't stated. We have a pair of angles that weren't stated. We have a second pair of angles that weren't stated. And we have a side that wasn't stated. We can say once our triangles are congruent, that any of those pieces that weren't stated, the angle A is congruent to angle D, the angle B is congruent to angle E, and the side AB is congruent to the side DE. And all of those would be by CP/CTC. Again, CP/CTC has to come after triangle congruency. And now we're going to talk a little bit about circles. Circles. Circles are named by their center point. So for my first circle right here, this would be called circle O. Now, the other way we can name this, besides saying circle O, is to draw out a circle with a dot in the middle, signifying that that's the circle's center, and name it by our center point. Now, on our second circle, we have this segment PA. PA is called a radius. A radius is just a segment that starts from the center and extends to a point on the circle. Now, PA, PB, and PC, those are going to be three of the same. They're called a radii. Radii are the plural of a radius. Which brings us to our theorem for this section. This theorem states that all radii of a circle are congruent. So if I have a circle, and my circle is circle A, and I have more than one radius, I can say that AB is congruent to AC, the reason being all radii are congruent. So let's go ahead and let's start some of the examples from this section. So here we go, let's get started with our first proof. We're given circle P and we're trying to conclude that AB is congruent to CD. So let's go ahead and let's make out our statements and our reasons. So we're given circle P. The only reason why we're given circle P is to know what the center is, therefore we can find our radii. Now, we're trying to conclude pieces on our triangle, which I'm thinking might be a CP/CTC step. Keeping the end in mind, to prove triangles congruent, we have to either have three congruent sides, two congruent sides and an included angle, or two congruent angles and an included side. So we need three separate pieces of congruency. So I'm going to start off by naming some radii, and I'm going to match up my sides. The way I'm going to match them up, and there's other ways we can do this, is I'm going to say PC is congruent to PA because all radii are congruent. Put in my tick marks here. I'm then going to go on to say that PB is congruent to PD. Again, all radii congruent. Looking at my picture, I see that I have intersecting lines, so vertical angles are going to be formed. Angle CPD is congruent to angle APB. The reason vertical angles are congruent. Now, have two sets of sides and an included angle. I have enough to say that triangle CPD is congruent to triangle APB by side angle side. When I wrote out that congruency statement, I was very careful in how I ordered it. C was made up of an angle that had no tick mark and a 1 tick mark on it, just like angle A was. P had a tick mark on it, so did P, and angle D was made out of rays that had no tick marks and 2 tick marks, just like B. Now, what I have here is I have 3 pieces of information that hasn't been stated. I have one side that has no tick mark on it, and I have 2 angles that have no tick marks on them. Those are going to be CPCTC pieces. Now, CPCTC, going through those letters. The CP part of this is corresponding pieces, which means that pieces that would match up on my congruency statement and pieces that would match up on my picture. The second part of congruent triangles, which means congruent triangles has to be a prior step in order for me to use this. Last but not least, those pieces are congruent. So the CP is corresponding pieces, the CT is of congruent triangles, the other C is are congruent. Now, the CPCTC step that I want is that AB, which is one of my sides without a tick mark, is congruent to CD, another side without a tick mark. I can go ahead and say that AB is congruent to CD by CPCTC. Now it's your turn to try one. We're given circle O. We're also given that T is complementary to MOT and S is complementary to POS. We're going to prove that MO is congruent to PO. Let's press pause and let's see what you can do. So here we go. We got our statement. We got our reason. We have circle O. We have angle T is complementary to angle MOT, and angle S is complementary to angle POS. Those are all given. I don't get to put any pieces of congruency in here. So next, let's look at what I have. I want to prove that MO is congruent to PO, which are sides of these little triangles here. Now, in those little triangles, I have some radii. So let's start off with that. I'm going to say that TO is congruent to OS. The reason all radii congruent. And let's go ahead and throw those tick marks in. TO is congruent to OS. The next thing that I see here is I have these intersecting lines forming vertical angles. I'm going to say angle TOM is congruent to angle POS. The reason? Vertical angles are congruent. And let's go ahead and let's throw those tick marks in. Now, next, I have my 2 lines here of complementary. Angle T is complementary to MOT, S is complementary to POS. I see that I have a repeat within my complementary steps and my congruency step. POS repeats. This is MOT and this is TOM. Let's compare those. Let's see. MOT is this angle right here with the double ticks. TOM is the same angle. It's just the letters are reversed, which is okay, which means that I have a repeat here as well. Now, what that means is those angles that are left over in the complementary step, angle T is congruent to angle S. The reason is that they're complements of congruent angles. And complements of congruent angles are congruent. Let's throw those ticks in. Now, here's where that leaves me. Looking at my triangles, I have 2 congruent angles and an included or smashed side. I have triangle congruency. I'm going to say triangle TOM is congruent to triangle. Let's be careful with my tick marks. I I got a double tick mark, and I'm actually going to throw a line through it. Just a plain old double and a nothing. So triangle TOM is going to be congruent to triangle SOP by angle side angle. Now, I'm trying to prove that MO is congruent to PO. MO, PO, those are sides of my congruent triangles. MO is congruent to PO by CPCTC. And we're set. So here's the answers to the homework. Again, we had 1 through 5 odds and 9 to 21 odds. So I give you the number of steps for each proof. I want to see what you can do with it. Now, number 21. It is a really difficult proof. So what I want you to do with number 21 when you try this is kind of keep the end in mind when you're actually going through your proof and think about what triangles need to be proven to be congruent. As always, have a good one.